Welcome, everyone. Tanzu Tuesdays. Uh, my name is Dan Vega, and I'm your host today, alongside my good friend, my fellow Spring Developer Advocate, Deshaun Carter. How are you doing, Deshaun?
I'm having a good day.
All right. We are lucky enough to have Christoph Strobl from the Spring Data team. I'll bring Christoph back in just a second. How you doing, Deshaun?
I'm hanging in there. I'm surviving. I have all my digits. Yeah, things are good.
I'm really excited because I've been not a huge fan of daylight savings times for as long as I can remember. I'm glad that it's starting to get like stay light out longer here. But I saw that the Senate had passed a bill to get rid of daylight savings altogether, which I'm a huge fan of. So I'm excited. I hope that gets through and that we don't have to deal with this anymore. And anyone who's not in a location where you have to deal with daylight savings time, I'm sorry if you don't understand it, but it's a huge pain in the butt.
I agree. We had a little mix up over the weekend where somebody was flying in, hanging out at the airport, and missed their flight by 1 hour.
Oh, geez. Always fun.
Time zones are
Well,
hard.
cool.
Daylights.
Well, cool. Today's going to be a lot of fun. We're talking about one of our favorite topics, something that both you and I have been doing a lot more of a deep dive into lately, and that's Spring Data. And so we're going to have some fun talking to Christoph about that. But before we do, I just want to talk quickly about Dotnet Beyond. So Dotnet Beyond is coming up next week, March 30th through the 31st. This is a 2-day free conference that will be streamed on both Twitch or YouTube. And if you go on the website here, I wonder if Deshaun, if you could throw that link in there. This is you can look at the calendar and just look at all of the events we have lined up. So a lot of really great speakers on a really great range of topics. And again, this is 2 days. Next week, March 30th and the 31st. And again, it's free. So I don't know how you can say no to free. So go check this out. And with that, I'm going to go ahead and bring in our guest, Christoph Strobl. Christoph, how you doing?
Hey there. Yeah, I'm good. Actually, we are having the time zone shift next week, so all the fun is still ahead of us. But yeah, I'm doing great. Good to be here.
Cool. Well, we appreciate you coming today to talk to us. If you could just give us, just so I don't do it an injustice, just tell us a little bit about yourself and what you do here.
Yeah, I'm Christoph. I'm part of the Spring Data team at VMware, and I've been doing this for, oh my gosh, I think it's been 8 years now. So I started off with Redis and Apache Solr, doing the Spring Data integration there, and then moved on to MongoDB stuff and did a little bit of JPA and comments as well. So I got a little bit of insight in both the SQL stores as well as the NoSQL ones. And I'm mainly doing MongoDB and Redis these days. But yeah. And for the time zones, I'm living in Austria, so it's already dark outside. And looking forward to moving to a standard time next week then.
Yeah. Yeah, it's always nice when it can stay light out a little bit longer. I know that when we get towards like October, November around here, it starts getting dark at like 5 o'clock my time, and I can't get off of work and just go into darkness. Like it's not good. And I think one of the reasons they do want to end it is because there is such a thing as seasonal depression because of that. Because it's like, hey, I just got off of work and it's dark outside already. You can't go for a walk or play outside with the family. Like it's not fun. So I'm glad to see it hopefully going away.
It's a relic. It's
cool. So before we get into the presentation, Christoph, do you want to just kind of talk at a high level what we're going to talk about today?
At a high level, we're going to talk about persistence with Spring Data. So basically explaining what Spring Data is all about, what it can do for you. I'll be using as an example, a SQL store, since most people will be familiar with those, and the Java Persistence API. And we'll be looking at a NoSQL store as well, like in this case, MongoDB, which is a document store. It's coming from a SQL world. It's pretty easy to grasp when you see MongoDB, because it looks familiar in some sort of way, though it has differences, and we'll get into those in the talk. And what I want also to do is give an outlook what the team has been cooking for the upcoming 2.7 release, and as well the next major upgrade with the 3.x line. So we'll be looking at some of the features and what the team has planned there.
Excellent.
Cool. I know Deshaun's excited about that. Cool. All right. I think so. For all of the viewers out there, if you have some questions, go ahead and ask them in the chat. What we'll try and do is, if they're relevant to what Christoph is talking about, Deshaun and I will pop in and maybe ask that question to Christoph and have a discussion around that. If it's not really relevant to something Christoph is talking about, we'll leave that to the end and then see if that's something that we can address today. If not, we can always take that offline. So, all right, with that, Christoph, I'm going to go ahead and throw you on screen and let you have at it.
All right, let's go.
Right. So perfect. Thanks again for having me. And we've already been talking about this. Data is basically essential to most of our applications. And luckily, we can choose from a variety of stores these days. So there we have the huge SQL market, as well as the NoSQL stores. And we can pick and choose the one data store that suits best our application's needs. And of course, with this variety of offerings, also there is a bit of downside, because each and every store has its characteristics, the way it works, and also the way you interact with that store in terms of the API that it exposes and that you potentially have to get familiar with, just to make use of the features, may it be the very basic features or a more advanced usage. And when we look at even the space of SQL stores, then we have the query language there, SQL, of course. And yeah, so I put up there a very simple SQL statement that you can run with the JDBC template, if you're familiar with that from Spring Framework, with parameter binding, just to get a list of employees, in this case, that match a certain criteria, a first name that is bound to a parameter. And you want to get all the results from the SQL store there, may it be Postgres or whatever you prefer, MySQL, what have you. And over the time, people started to decorate that API, because typically what you don't want to have in your application is strings, huge amounts of strings that are error prone. There could be a typo in there and whatnot to interact with the data stores. So over the time, something got up that was the JPA, Java Persistence API, that lets you express the queries in a more developer-friendly way, I'd say, or at least in a Java world-friendly way. So you can use your entities and the properties in there to express what you want to retrieve from the data store, and it does typically all the ORM mapping for you. So it will map the columns and the field values to your domain model. Next, of course, since some people don't like JPA and the way it works, there is Juke, which has a more fluent API and its internal optimizations. And this looks more Java friendly, because it still feels familiar if you're coming from a SQL world, because you still have all those keywords like select and from and equals there. But it gives you another level of abstraction onto your data. And yeah, then we have the huge amount, that huge space of NoSQL stores. So the query language for NoSQL stores differs pretty much from each and every store you're looking at. So if you're looking at the document store like MongoDB, as I said in the introduction, then the very same query, just selecting a list of employees from, in this case, a collection, looks very different to the SQL representation. And the same is true if you're using something like Neo4j, a graph database, where you're dealing with nodes. So the query looks completely different there. And you first have to understand the Cypher query that you're writing in order to get the data out of your store that you persisted there. Or a search engine looks pretty familiar with looks familiar to the MongoDB API, still because it's using JSON, but that's about all of the similarities, because it's using a query language that is really up to the search engines capabilities like Elasticsearch has. So we see there is lots of different APIs to interact with the stores. And now, what if I told you that you could have all this expressed in a human readable method within an interface, basically, so that you just follow a given pattern, and that's all you have to do, just declare this. And this works across multiple stores. And that's basically what Spring Data can give you, and how it what it offers on the top level. Still, Spring Data is not a magical tool, but it's rather it gives you an entry point, and behind that entry point, it's composed of typical mechanisms that we have in the Java world. It's proxies, a default implementation, and delegation. So there's nothing magical about it, and I'll show you that in a bit. So when we look at the typical anatomy of a Spring Data implementation for a specific store like JPA or MongoDB, then on the top level, we got something that's called the repository interface. So the repository interface is the entry point that you expose to your consumers to interact with the data store. And this is typically where you put all those find methods, those methods that you saw before, like the find by first name, and it will give you a list of employees. And those repository interfaces are backed by a store-specific default implementation. The default implementation is then based on either the entity manager in case of JPA, or, oops, wrong button, or in the case of a NoSQL store or the Spring Data JDBC, it's based on the template API. And the template API is responsible for resource and transaction management, as you're used to when you're using any other Spring related template API. So that's what it does. And the template is typically very close to the native driver implementation, just a very tiny abstraction that takes care of binding resources to a thread in case of a transaction and releasing them afterwards. And the template API is backed by a mapping layer. And this mapping layer is responsible for taking your domain objects and converting them or mapping them to a store native format. So in the case of MongoDB, the document store, it will take the employee object and then create a document out of it with all the fields and nesting. We'll see an example later on in the presentation. And the mapping itself can be configured via a conversion engine, and the conversion engine is there to tell how to map a certain type or how to convert a certain type into the store specific representation. So this could be, for an example, if you take an enum, you could tell the conversion engine to just convert the enum to a string, or maybe you'd like to have the ordinal of that enum within your store persisted. That's something that the conversion engine then does for you. And all this, of course, sits upon the specific database driver. Maybe some SQL driver, or a MongoDB or Cassandra, or even a driver for Elasticsearch. This doesn't actually matter that much. When we now go on and look at the template level, which is responsible for backing the repository implementation, then I already mentioned that one is very close to what the driver offers. So you'll find all the methods there that allow you to run queries, to add data to your data store, to remove data, or even to access underlying driver functionalities. So what you typically find there is an execute method. And the execute method takes then a callback, which is specific to your store. So in the case of MongoDB, we're talking not about tables like in the SQL world, but we're talking about collections. So you would get, if you call the execute for an employee, then you would get the collection that is associated with the employee and holds those the documents there for holding the employee data, and then you can run your queries directly using MongoDB driver API against the data store. Again, since you're consuming the driver API via the template, resource management is none of your concern, because all of this will be handled transparently by the template itself, so that you don't have to care about it. Like in the case of MongoDB, for MongoDB, when you take it, it's a document store, and typically all update operations on a single document are atomic by default. But you could also modify documents within different collections, and though each of these updates would be atomic individually, the whole update itself, so the modification of both collections, would be, so you'd have to encapsulate those within a transaction, and the execute method will detect, hey, there is a transaction ongoing, and will participate in all that stuff. So that's all taken care of if you're using the template API, if you're using the driver via the template API. So now let's dive a little bit into what actually a repository is composed of, because there is various ways how you could configure the repository interface, so the main entry point for consumers of your API. And the most simplest thing is to just define the interface for your domain type, and the second argument would be, the string in this case would be the type for the ID, and then you extend the repository. And repository is nothing more than a marker interface that lets us know, hey, this is supposed to be a Spring Data repository, and we gotta kick off all the instrumentation around it to back it with the default implementation. Right, so the repository, as said, is a marker interface. It doesn't have any methods by itself, so it's empty. So if you declare it that way, you wouldn't be able to do any operations with the repository as it is. What we also got is a set of predefined interfaces that you can extend from. Like we have the CRUD repository, and as the name already tells, it's there for doing all the CRUD operations that you have to do, like saving, deleting entities, finding them by ID, getting all entities, counting them, and stuff like that. And we got, as an extension to that CRUD repository, a paging and sorting repository that lets you extract just chunks of data, so that you don't have to use find all the time, but you can say, hey, give me the first 10, 20, 50, and then the next 20, 50, what have you, entries within the store. And or you could just sort stuff as you like. Still, there is a downside to using those predefined interfaces, because once you're using them, you'll expose all the functionality that is declared in there. Let's say you just wanted to have a read-only repository, then CRUD repository wouldn't be the choice that you should take. But instead, what you could do is, if you wanted to have expose just a certain subset of functionalities, you could extend repository and then add methods that match the predefined ones to your repository interface, and will happily pick those up, and you limit the scope of what you expose to the outside world. So you, in this case, if you just picked repository, nobody would be able to save anything in there by intent. And as I said before, typically those repositories, along with the extension points, may it be CRUD repository or what have you, is proxied at application startup and backed with store-specific default implementation. And that's how it actually works. So you could define your derived finder method in there. And once you try to, you call that method, the proxy detects it, sees, hey, this method matches one that is predefined and it exists in the default implementation, and then it just goes right there. Or it detects, hey, this is a derived finder method, so I need to extract the query from the method name and then run that particular query that you defined in there. And that's pretty much it. That's how it happens. And what you then have to know is basically the patterns that the finder method and all the repository methods follow to be able to solve all those everyday tasks, like finding employees by their name or doing stuff like that. So let's have a look at such a finder query and what it consists of. So you can split such a query apart, and then typically the first thing you see when you go from left to right is the return type. And the return type is there to tell us what kind of query you're trying to run. So should it be a collection execution? Do you want to get a list of something? Or should it be just a single element, like give me just one single employee, and if it's not there, then potentially throw an error at my face because it should be there and I expected it to be there, unless you wrap it in an optional. Then of course the optional would be empty. You could request a page, like I said before. It's like paging through your data, give me 20 and then the next 20 and so on. You could also use a slice. And if you question yourself, so, well, what's the difference between a page and a slice? The page will tell you how many pages are there in total. So it will tell you there are 1,000 entities that match your query, and there will be 100 pages or so. Whereas a slice only gives you the selected chunk of data. It won't perform any count, but it still can tell you if there is more. So you can ask is, hey, is there a next slice? And it will tell you, yes, there is, or no. Or you could, if you prefer, and if the store supports it, so it's not available for all the stores, use a Java 8 stream to just stream the data from the store and consume it that way. The next thing is the keyword. If you don't like find, there is others to choose from. You could use read, get, query, search, stream, whatever you prefer. And then there is some space for you to fill in so that you avoid method clashes, or that you can identify the method that you're writing a bit more. So you can also leave it out, so that the employee part. And then there is our delimiter, which is by. And then we got some property matching, property and method argument matching. So you see there is the employee has a first name, so we put in the first name there, and of course it should then match what the first argument. If there was a second one and last name, then and the method would have to take a second argument. And then we got the match operator that tells us what to do with the given property, how it should be matched. So there is lots of operators that we support. There's between, greater, what have you. And optionally, at the end of the method, you can also put in some ordering and sorting and what have you. What you already see here is that those method names, especially when it's a more complex query or it takes more arguments, can eat up quite a lot of space on your screen when you're typing it. So what you could do is you could even push that one out to a properties file. So we'll detect that if there is something matching in the properties file, then we could take a query from there and stuff like that. But that's a more advanced usage of the API. Right. And of course, you cannot just do finding stuff with that pattern, following that pattern for deriving queries, but you could also use other keywords. And in this case, you could do count queries. The difference is it uses another keyword and it returns obviously a different type. The same is true for exist queries, and some stores even allow you to modify your data and remove entries from your data store with a query. Like in this case, it would be the delete or remove keyword, and then the derived query, what have you. And some stores allow you to get back the number of deleted entries. Some don't. In this case, it would be void. Some even allow you to get back a list or a collection of the entries before they got removed. But that's very store dependent, and not all data stores support it. But in general, the functionality is there. And once you understood the pattern, it's pretty easy to apply. Another interesting thing is that you can limit the data you expose to your clients in a very easy way. So you remember when I talked before about limiting the methods that you expose by just choosing the empty repository interface, and then just selecting those methods you really want to expose. The same is more or less true for the return value of methods. So what you could do is you could return a few onto your data that is hiding certain aspects, like an employee, and you don't want to expose the social security number, but just the first and last name. What you can do is you could define a class whose properties match the ones that are stored in the database, and then use that as a return type. In this case, we call this a DTO projection. In this case, we'd be able to see, well, the return type doesn't match the type that is defined in the repository interface. Still, the properties match. And so we can just select those properties from the data store. So it's also a very efficient way, because we don't go ahead and just select everything and then map only 2 fields, but we go really full circle and say, hey, just give us those 2 fields and we'll expose them to the caller then. What you also could do, and we call this an interface projection, is instead of a class, define an interface with just getter methods to the fields that you want to expose, in this case, first and last name, and leave out all the others. This will also be backed. This will be proxied and backed with the result, and converters will be applied. But it's a very convenient way to even limit the access to the data more. And we got a third one, and this is the most flexible one. That's why we call it an open interface projection. And this is something where you use Spring's add value annotation to grab stuff within the result that is coming from the data store and then manipulate it in whatever way. So you could, for instance, take the first and last name and combine the 2 and expose them as a get name function.
This is huge right here. I just wanted to interject like this.
Sure.
This little step right here, where we go from like the regular CRUD that everybody knows across all the different flavors of data store to this, is a huge leap in the things that you are able to do easily. And then also like performance, right? Before we had this projection, we were jumping straight from, hey, here's my CRUD, grab all the things, to grab all the things but only return these to the front end. But I was still grabbing that massive amount of data. If there was, dozens of columns, let's say, I was still grabbing it and then just returning parts of it. This was a huge time saver, performance improvement. And then just the way that you thought about modeling your data, you didn't have to have these one-off tables that were the exact same. Sometimes I had a lot of the duplicate data over here. I didn't need to do that anymore because I had these projections. I just had to add that. It was a beautiful, beautiful day for me when I learned about these options.
Nice. Thanks for sharing this.
Yeah.
It's great to hear that.
I was gonna ask a question along those lines. So this is a big kind of performance gain because we're only kind of selecting the data that we need to return back. So I think I'm going to answer my own question here, but I just want to make sure that I'm clear. Most of the time, if say I just wanted to like hide the ID from like a JSON response, right? Like I don't want to return the ID back to the caller. I might use like something in Jackson to just hide that ID and say, don't return this in the response. For that case, is that okay? Is this case like, hey, I have, an entity with like 20 columns, but in this case, I only need to return 2. Is this a good solution for that scenario?
Absolutely. So at first, we've been using this for Spring Data REST mainly. And then we thought, wait, this is really a good idea if we just pull it down one layer and then expose it for all the data stores so that they can make use of this for just really limiting the data and the stuff that goes over the wire to improve performance and to just also make it secure, because what's not in memory cannot be exploited. Because if the social security number or a password isn't there, how would you get hold of it? It's not there. You cannot access it.
Yeah, and then even in my case, when I'm hiding something using Jackson, it's still there. We've pulled it from the database, so there's a performance hit there depending on how much data we're grabbing.
So on the view side, what I ended up having, and this is just one way of doing it, right? The DTO, the difference between that DTO, and we had this question in office hours, the difference between what we're going to show versus what actually exists in the back end I had different DTOs based on the user's roles. Like what were they trying to access? So same table of data, let's say, but a normal user only gets to see these things. So that table DTO only showed the things that that user was able to see. But for like an admin, it'd be an admin table DTO, and they were able to see perhaps the ID if we deemed so. Right. So that was just one way of against the same document or table, having these different views of that was only getting the things that it needed to or had access to, so that now your JSON JSON stuff was much easier because you're only going to have access to what you had privileged access to.
Yeah, nice.
I have a quick question here from Furlog. Is there a way to only return a reference to an object? The old get1 method seems to be deprecated. Are you talking about just find by ID, like that type of thing, Furlog? Right, like the CRUD repository contains a way to return a single object. I'm not sure what they're talking about here with the reference to. Does that make any sense to you?
I'm sorry, me neither. There's the find one method still. I know we changed it to return an optional, which some people might not be happy about. But still, other than that, I hope that answers the question.
Yep, cool. Thank you. All right. Sorry for the interruption, Christoph.
That's fine. That's fine. So let's move on. I don't recall if I finished the interface, open interface projection. Nevertheless, just for completion, I think I should mention, if you're using the add value annotation to look inside or compute values for a projection, in this case, since we don't analyze the spell expression that's used within add value, we go ahead and load everything that's related to the entity because we just can't tell upfront which properties you would want to use. So the first two options are limiting the data. The third option, most flexible one, still downside, you'll load more data into memory. Right. To round things off a bit, Spring Data also, of course, offers a reactive API, and there's really not much to say about the reactive API per se, because it really looks just like a normal repository. The only difference is that it returns either a flux or a mono, which are reactive types for streaming data. And of course, the whole execution model is completely different, and we could spend hours talking about that, but that's not what we're here for. So just so you know, Reactive API, same concept, just a different approach for the data types and the execution model. Still, though, we have all those capabilities. Spring Data is not meant to be an API for all the data stores that are out there, because they just aren't the same. A SQL store is different from a document store, and what this exactly means, we'll look at that right now. And it already starts with your domain model. So I took the employee that I've been talking about for a while already, and just put them up on the slide for, let's say, JPA and MongoDB. And what you already see there is that it looks different, though the properties themselves may be the same. The annotations that you're using are specific or will be specific to the data store that you're using. Like we have the JavaX NTT annotations and the generated values and columns for JPA. And we have a document annotation identifying this will be stored as a MongoDB document. And the columns aren't columns, but are fields of those documents. So you'll see a reflection of the data store in somehow within your domain model. So that's where it starts. Of course, since those stores are fundamentally different, also the storage format, though you won't see the actual storage format in your domain model, is there, and you have to be aware of how things that you model in your domain are persisted within the store in the end. So on the left, we have the table-based approach, and where linking between entities is the default. So if you have the employee, and the employee has a manager, and the manager is responsible for numerous employees, then typically in the JPA world, you'll have two tables, and you'll have a reference from the employee to the manager and establish the link in that way. If you're looking at a document store where basically everything is inside a document, because document updates are atomic by default, it may look different. And if we look at the stored manager there, then the list of employees may be directly embedded within the manager itself, which would be the document store default behavior. So the representation within the store is completely different, though the model looks somehow familiar on the Java level. Of course, there's typically means to teach each and every store to behave differently. So if you want to exchange the embedding default of, let's say, a document store, there is typically means using annotations like a dbref in MongoDB to tell it, don't store the entire document or embed the entire document within a list of employees, but rather use a reference and store the employee somewhere in someplace else in another collection maybe, then you can do so. And the same is true with JPA. You could use embedding and stuff like that to store data within the same table and not split it up depending on what you do. And what also comes with this different native store representation is that queries that cannot be expressed using the query derivation that we talked about before will look differently. So typically, each and every Spring Data implementation, maybe MongoDB, JPA, Cassandra, Elasticsearch, what have you, has means to add an add query annotation to a repository finder method and then run store specific native queries. In this case, let's say we have a JPA store and we want to select a manager or the name of the manager along with how many employees he has without loading a list of employees, but just using account function there. This is something you typically express using the add query annotation, and I have on the screen what it would look like for JPA basically. With MongoDB, it's different because MongoDB, though it has this add query annotation to run native queries, MongoDB doesn't have the means to run count queries within such a select statement, more or less. But what you'd have to do with MongoDB is you'd have to use something called the aggregation framework. And the aggregation framework goes there and basically projects the size of the employees array that we saw before to calculate the number of employees that a manager is responsible for. Because if you remember in the slide before, we had it, just let me bring it up. We had this employee collection here, and what we do is we just select the size of this collection, of this array within the document. So you see, you have, depending on the store, to know how to access data once you exceed the space of what a derived query can do for you. And also very store depending, and what you've bought into is the number of the functionality that Spring Data exposes to you. Because if you're using a SQL store, you might be able to call the store procedure very easily by just having a procedure annotation that comes with Spring Data JPA, but you won't find an add procedure annotation in any of the other store implementations, since they just don't support store procedures, most of them. On the other hand, for MongoDB, it would be able to define an update clause and then modify documents within the store based on a selection query. That's something that you can do there. Or if some of the stores allow you to run geospatial queries, in this case, you could select offices that are near a given point within a distance and then stream those results if you want to. And if all of this is not enough to satisfy the needs that your application has in terms of how you want to access and manipulate data, then there is something that comes on top of this, because you can very easily extend the capabilities of a repository just by adding your domain-specific custom implementation, whatever that may look like. And this is very, very easy to do, because all you have to do is you add an extra interface or multiple extra interfaces. It's totally up to you, to the repository interface declaration, and we call those extension points fragments. We use those fragments internally ourselves, like we have extension points for query DSL, for example, or for query by example. And we pick up those implementations ourselves with those fragments when composing the repository. Nevertheless, you define an interface, add it to the repository, provide an implementation of that interface that can use all the Spring functionality. So you can use auto-wired and stuff like that, and wire in beans or instantiate it or make it a bean itself so that it lives within the container explicitly, and we'll take care of picking those extension points and extension implementations up, wrap them within the proxy, and then delegate to your specific implementation if you call a method.
This is great. So, I have also been in the ecosystem. I can go and Google, right now, like, hey, I remember when Spanner was introduced, there wasn't Spring Data JPA support, even though we knew it was going to be similar. A lot of us were out like, oh, well, we're just kind of waiting on Spring Data for Spanner. And then some of us realized like, hey, I can go and follow these same conventions and I can build my own extensions fairly easily. So just based on what you've kind of shown, I know that there's tons of Spring Data options. We saw a big list, but I've also seen a lot of these other data stores. They're looking like, hey, is there Spring Data JPA? You can go Google any of the other ones that don't have one already, and you'll find somebody looking for a Spring Data extension. And I think what I understand right now is that it's fairly easy, even if I don't fit the mold of having those same default implementations, default interfaces, I can easily extend it. And that's what you just got to here. I could easily extend it to kind of match the language or the conventions for whatever data store. And that gives me an option to have maybe that transition from Spring Data Postgres or whatever I was using today to whatever I'm using next. It gives me a way to transition and lowers the friction for the teams that might be using it. I'm just a big fan. That was a clap. That's all that was.
Nice. Thanks. Right. So, still, what I want to warn you about, just by using Spring Data, your app will not be safe from any issues. So what you will still have to deal with is trouble, like, hey, the application is slow for whatever reason. Well, this happened to all of us, but what we can give you and what Spring Data and the Spring ecosystem in general provides you with is we integrate with JFR, the Java Flight Recorder, and expose metrics there. We also write a lot of log files, so there's plenty of them to find out what's wrong if things go south and the application doesn't work as you expect it to do. We expose, if you're using Spring Boot, actuator endpoints that let you measure repository method invocation times. It's a bit tricky to configure those, I must admit, but there is documentation for it, and you can definitely figure out how to get access to that data. And we're working hard to make this even easier. Sometimes it's just a bad switch. Unfortunately, this still happens in some data centers, or a missing index. Nobody's perfect. I even had cases myself where I ran the query and I was sure the index would be used, and then a query planner decided against me, and I had to provide additional hints to just make sure, please go ahead and use that index, even if you decide it wouldn't be for the best, but I knew better. The point is, there is help there. Just don't freak out. We expose a lot of stuff. Just make sure to have a look at it. Right. So, last words on what Spring Data can provide you with, and the key takeaways that I want you to have from this introduction is Spring Data tries to make your everyday tasks as easy as it can be. Just please don't fall for the assumption that you could swap out the underlying store easily because it feels like you could. There's downsides to this. We really want you to have a familiar programming model. So once you saw a Spring Data repository in one store coming from JPA, and then you move on to, let's say, Cassandra or MongoDB, then just by looking at the repository, you'll get an idea what will happen below. So that's what I want you to remember from this introduction section. And with that, I'd say let's have a look at what's coming next. What has the team been cooking over the last few months and will be cooking during the rest of the year. Just for safety reasons, everything that I'm now going to say is forward-looking, so it mustn't happen just exactly the way I tell you. Some things might not happen at all, but that's rarely the case, I must admit. So let's jump right into this. You probably remember the conversion engine that I talked about before, where you could tweak how certain types are represented in the store itself. We've been having this mechanism for quite some time now, and what you've been able to do so far is you could provide a converter implementation for a specific type. Let's say if for a person, so if you wanted to address or do something different for, let's say, the social security number of a person, you'd have to write a converter for the entire person object just to treat tweak the representation of one specific field, because you wouldn't want to write a converter for a string to a store specific implementation, because that would apply to all string types. So it would also apply to the name. So the only possibility for you to tweak the representation of a certain field was to write a converter for the entire object. And this was a bit, well, unfortunate and did not serve everything people wanted to use. And so for the upcoming release of the 2.x line, we'll be introducing something called property converters or value converters, which are then specific to a certain field of a domain type. And we have two ways to configure those converters. One would be using the declarative approach. So there'll be a new annotation at value converter, and you can then pass in the type that will be responsible for the conversion, and we'll create an instance, or if it's an enum, we'll just take the enum value and what have you. It could even be a bean within the context, so we'll resolve those. That works perfectly fine. And then apply that converter to just this specific field. So you could have something like an encrypting value converter that ciphers the social security number when writing it to the store, and then deciphers it when reading. So that would work. Next to the declarative approach, wrong button, we have a programmatic one. So what you can do there is you have something called a property converter registrar, and then you can use register a regular Java util function for reading and writing a specific property. And we even have, you can even make this type safe by using the reference there, and then it will make sure that the reading and writing converters can only be accept the type that is used for the getter method. You could also use a string representation, that's perfectly fine, but that doesn't support the type safety because we cannot infer the type in there. But with this approach, this is possible. It's just a little bit syntactic sugar, but quite useful if you like the type safety features.
Hey, Christoph, just a couple of quick comments. Nice improvement on the property level converters. So you already got a big fan out there of that. And then did you say I can use enums there as well?
Yes, the encrypting value converter could implement the value converter implement interface and be an enum. And once we see, hey, this is not a regular class or it's not a bean, but just an enum, then we'll just go there and pick the first value and then use that. Because some people like to use enums for singletons,
Yep.
and it's just a convenient way. So we'll pick that up.
Cool.
Thanks. So moving on. So this was one of the bigger features of the 2.x line that I wanted to show. What's next is what we have planned or are planning for the 3.x line. That should be released somewhere end of this year, maybe early next year. We'll see. We're not entirely clear on the release. Still, it will include several updates since we now have the option to do so. So we'll move the language level baseline from 8 to 17, switch to the Jakarta EE9 namespace along with all the package renamings and stuff going on there. We'll have Hibernate 6 validation API. Of course, we need to change the CDI extensions. Several store modules will upgrade their dependencies, like for Redis, there is a major upgrade like we have in Redis 3 at the moment, and latest releases are targeting already Redis 4, which has a lot of breaking changes. And in order to do the upgrade, we really need a next major release there. So we'll use the time to upgrade also dependencies for some of the modules. Something that I personally like very much is are some API refinements. Dan already thankfully did a great video on some of those yesterday. I put the link up in the QR code there. I think we'll share the slides afterwards anyway, so you can have a look or just subscribe to Dan's channel and watch the video. Nevertheless, I want to take the time to talk about this briefly today. And what we have so far is we have for the repository, we have the repository on top, and then we have CRUD repository that is extending the repository, and then we got the paging and sorting repository that is extending CRUD repository. So we got this type hierarchy. And the thing that many people are concerned about is like the CRUD repository and defined methods there that return more than a single result are by default using iterable. And there have been numerous requests and discussions to move away from iterable, because typically what you want to have in your application is not an iterable, but a list or a collection or a stream or what have you. So something that's not an iterable, something more workable, I'd phrase it that way. And there had been some internal discussions over years in which way to change this arrangement. And what we've come up with so far is now we introduced next to the CRUD repository a list CRUD repository. Not a big change. It just redefines the find methods like find all and save all to just give you a list instead of an iterable. Of course, you'd be free to still override the find all methods and then just return a list and still use CRUD repository. That would work because we have adapters in there that adapt to whatever return type you have. But now there is explicitly something that you can extend from, and then you don't have to redeclare your find all method. Not a huge improvement, but a handy one, I'd say. And what we also had is we had to redefine the hierarchy, since we have the paging and sorting repository, and you wouldn't be able to have this. So we split the hierarchy up. So paging and sorting repository no longer inherits CRUD repository, but is independent of it, because we can mix and match with the fragments that I've been talking about. And so the paging and sorting repository became something like a repository fragment on its own. So you can now combine it with either the CRUD repository and still use iterable and redeclare it, or along with the list CRUD repository. Just what you prefer. It's there for you. Very convenient, I'd say. Up next is we want to get even better at metrics. So there is already integration, like I mentioned, with the Java Flight Recorder. We're exposing actuator endpoints and whatnot. Still, we want to make we make instrumentation and metrics a first-class citizen within the data project, and we'll integrate with Micrometer in this case, which is a vendor-neutral instrumentation facade for whatever backend you have there, may it be Wavefront or Dynatrace or, I don't know, Datadog, what have you. So there will be something coming, and you'll get even more analytics data out of the repositories and your data access layer. And of course, we'll continue our efforts around Graal and Graal native to make sure that all the data projects work within a native image. We've been doing this already for quite a while with the Spring experimental with the Spring Native project, which is still experimental. And for 3.0, we plan to take those bits and just make them part of the Spring Data core and also the Spring Framework core. So we'll split that up. Stefan, I think, just today posted an excellent article, what we've already done for Framework and what we'll continue to do for the data project and also the larger Spring ecosystem projects. I linked the article also on the top right within the QR code. So all the static hints and the dynamic configuration that is required to make data access work within a ground native image, like for JPA, identifying all the annotations and opening up the entities for reflection usage that you need when you're using Hibernate, that's all part of that work. And some of it is already available. Just make sure to go to start.spring.io and select the latest boot 3.0 snapshots. And then you should be good to go. Like for the list CRUD repository, you can already play around with it today. And that's all I have so far. So thanks for listening.
Oh, cool. Thank you so much. That was awesome, Christoph. I appreciate the way you've broken down Spring Data, which is this large project, and kind of broken it down into its simplest form, which is a consistent programming model across data stores. So that was great.
Yeah, thank you. Yeah, there is always so much you could talk about. Like we have, of course, support for auditing and all that stuff. So event listeners and callback methods that you could use to modify stuff before it gets saved. So there's lots of other stuff that you could do, but this would take the talk way too far. And
we'll get you back. We'll have you come back and talk about
oh yeah, sure.
auditing and event listeners and callbacks. Yes, indeed.
Perfect. I'm all up for it.
I do have a quick question on the Spring Data 3.x line. Is that supposed to coincide with Spring Boot's 3.x, or is it just kind of coincidental that they're both heading towards 3.x?
It's no, it's actually the plan to align those. Also align it with Spring Framework 6, which will be the baseline, and that's why we want to upgrade. Also follow along Spring Framework with the upgrade to Java 17 as a baseline. So this will all then hopefully come together as a nice seamless offering for the users out there, and we're on the way.
And we're already behind. Java 18 was released today.
I know it's on my list.
It's hard to keep up.
Yeah, absolutely.
We're not behind. It's not on start.spring.io, so nobody's using it anyways.
Yeah. Absolutely.
No, I think just moving to 17 is going to be great for everyone. Just the thousands of performance and bug fixes that are going to be in there. So I'm looking forward to the community as a whole starting to move forward instead of staying back in the bad old times.
Yeah, and
cool.
I mean, you don't have that opportunity that often, because it really requires a major release, and you can't do those every 2 years. You have to wait, because with every major release there are pain points. Everyone knows that, and we try to keep the API as stable as possible, but unfortunately it's not always doable. It's like
well, as
we have a lot of options.
We as I said earlier, Deshaun and I have been doing a lot more work on the Spring Data side, so we are definitely going to keep bugging you in the near future. Maybe not for a presentation, but I'm sure we're gonna, we have another show, Office Hours, that we're doing, and we get a lot of questions from viewers on that. So if we get some Spring Data questions that we can't answer, we'll be sure to throw them your way.
Yeah, perfect. Looking forward to that.
This is great. Thank you so much.
This is great. Thank you so much, Christoph, for taking some time out of your evening. I know it's a little bit later there right now, so we appreciate you taking some time and sharing some knowledge with us. It was a great presentation, and we look forward to seeing what's next from Spring Data. So with that, folks, we're going to go ahead and end today's broadcast. Thanks again for coming.
Thanks for having me. Bye-bye.
Bye.